Welcome everybody to this launch for the report, Our Fluid Nation, the Impact of Fluid Dynamics in the UK. My name is Steve Tobias. I'm the Director of the Leeds Institute for Fluid Dynamics and a member of the Executive Committee of the UK Fluids Network. So a couple of bookkeeping issues. The event's being recorded and will appear online in due course. The report itself is downloadable as a PDF at the link that will now be placed in the chat. So the agenda for today takes the form of presentations followed by a Q&A session with panelists. Please could you put your panel questions using the Q&A tab, which hopefully you can all find. You'll also be able to see the questions that have been posed there, and if you think it's a good question, you can vote it up or ask a supplementary question, and then it will rise to the top and we'll be able to ask the panel. It's my great pleasure now to hand over to Professor Dame Anne Dowling, Deputy Vice-Chancellor at the University of Cambridge and Emeritus Professor of Mechanical Engineering. Anne was President of the Royal Academy of Engineering from 2014 to 2019 and was a member of the Prime Minister's Council for Science and Technology. So over to you, Anne.
Thanks very much, Steve. So I would like to add my welcome to Steve's and thank you very much for joining us today. Now, as we all know, fluid dynamics is an enabling technology that underpins many industrial sectors and a wide range of societal applications. But that breadth is both an opportunity and a challenge. A challenge because it means that the importance and impact of fluid dynamics can be hidden. So I'd really like to congratulate the UK Fluids Network on this report, which I've had the opportunity to read. And it really sets about quantifying the size and influence of fluids on UK businesses and its direct contribution to the UK economy. Some years ago, I was asked by Greg Clark, who at that time was the Science Minister, to undertake a study of business university research collaborations and to recommend how government could help initiate and support such relationships for the benefit of the UK. And it was a fascinating report to do. We found great enthusiasm for such collaborations and real examples of excellence. And there's absolutely no doubt that research can be truly excellent and be inspired by practical or by a business need. One of the things, so we highlighted what were barriers, what was at the heart of good collaborations, and at the heart of most collaborations that really work is a strong and trusted personal relationship between people in business and individuals, researchers in universities, and that's really key. But also is important to build a shared vision. And other things that are really helpful is mobility, making it easy for people to move back and forth between academia and businesses, and also having easy access to funding. Too many schemes, too many layers, too much bureaucracy can just place unnecessary hurdles there. Now, when you look at what's happening now, the UK Fluids Network's already addressing some of these. The directory really helps bring people together, and the special interest groups can help develop a shared vision. But there's a lot more to be done that can help fluids collaborate more easily and smoothly. And it's particularly important in fluid dynamics that we have some sort of coordination, because even within a single university, you find fluids research spread across different departments. And so coordinating and networking is really crucial. So I'm hoping that these will be opportunities that we'll be able to discuss further in this event this afternoon. Thank you.
Many thanks, Anne. Our next speaker is Professor Matthew Juniper, who's Chair of the UK Fluids Network and Professor of Thermofluid Dynamics at the University of Cambridge. Over to you, Matthew.
Thank you, Steve. I thought I'd start by answering the question, what is fluid dynamics? And fluid dynamics is the science and engineering of anything that flows. That can be gases like air, liquids like water or blood, plasmas such as in the sun, and anything in between. It's a technology with tens of thousands of applications, For example, weather forecasting, wind farms, aeroplanes, airflow in buildings, and most manufacturing processes. This report shows that fluid dynamics underpins the activity of over 2,000 companies across the length and breadth of the UK, employing 45,000 people, and crucially in high value added industries, which together contribute nearly £14 billion per year to the UK economy. Fluid dynamics is also central to societal challenges. These are harder to quantify, but just as important. For example, mechanisms to achieve net zero, particularly in power generation and aeroplane propulsion. Also, healthcare, pollution reduction, and many more. In a few minutes, Catherine Oakes is going to present some of the detail of the report. But before then, I want to provide some context, where the report came from and what we hope it will achieve. So first, the good news. The UK has always been and is still a dominant global player in fluid dynamics. Many of the equations are named after British and Irish researchers. We have an outsized presence at scientific conferences. The UK hosts the top journal in the field, top by impact factor and arguably also by reputation. And in that journal, the UK publishes more papers than France and Germany combined, and 2/3 the number of the entire United States. We are already a global superpower in this area. Crucially, the UK also hosts many global companies that extract and deliver value from that fundamental research. These companies are distributed across the entire UK, and their average gross value add per worker at £76,000 exceeds even that of London. The challenge is that the quantity and increasingly the quality of research from overseas, and particularly India and China, it's growing and it's making its presence felt. On the one hand, this is very exciting for the field, and for many of us, it is our own former PhD students and postdocs who are driving this growth. On the other hand, the UK's dominant global position in this field will inevitably slip away if we do nothing. Of course, if it slips away, the high value-added jobs in the UK and the local expertise and societal challenges such as net zero will inevitably slip away with it. Well, as they say in films, today is not that day. The UK fluid dynamics community is still a superpower. It is creative, it has world-class infrastructure, and it's collaborative. It has from the ground up self-organized into nearly 50 special interest groups across 60 institutions, focusing on different methods and different applications, and in collaboration with industry, particularly in areas where the UK already does well. This has been driven by the UK Research and Innovation Council, UKRI, which has invested £2.3 billion in fluid dynamics since 2012. And the advantage of investing in fluid dynamics is that you reach thousands of applications in one go. There will always be a return. It's just that the return may come in an application that you hadn't thought of. And that's because fluid dynamics investment can be repurposed quickly. And for example, the UK's world-leading research in building ventilation, primarily motivated by energy efficiency, was repurposed instantly for COVID, providing hard evidence for policymaking around ventilation. So in this report, we want to show that investment in fluid dynamics provides a great return on investment, even if that investment lies just below the surface. That value has been captured in the UK and crucially through high value added jobs everywhere in the UK, and that further investment is both needed to retain our global position and also would be well spent on the industrial and societal challenges that we face today. So that's an introduction to the context of the report. There'll be a chance to talk about it in more detail in the panel discussion later, but before then, I think Kath is going to talk. Oh, before then, we got others. Sorry, Steve, back to you.
Thank you, Matthew. Today is not that day, as you say. Very good. Okay, so our next speaker is Professor Paul Monks, who is Chief Scientific Advisor for the Department of Business, Energy and Industrial Strategy. So over to you, Paul.
Thank you, Stephen. Thank you, Matthew. Thank you for inviting me to come along and talk today. Kath approached me actually to write the foreword for this. I'm not going to read out my foreword because hopefully you'll look at the report and do that. And I thought, oh, fluid dynamics, that's a good thing, isn't it? You know, as an atmospheric chemist, you know, I've been aware of CFD and all the good things that come from that. I got the report and I went, wow, this is incredible. Did I realize this supported a £13.9 billion industry, 45,000 people and 2,200 jobs? I didn't. And I think that's really struck home to me. This very week, actually, I went to a visit to a Formula One team, and this is not for me showing off about my travel diary, you know, and it was really struck home the importance of aerodynamics to them and the importance of fluid dynamics as part of that. And 7 of the 10, I think, Formula One teams are based in the UK. You know, a great industry, absolutely dependent on fluid dynamics and aerodynamics and the like. So really, this is an area of true excellence. And I think why I was really happy to put my name to this report, if you will, was it's just an amazing science story and an amazing industrial impact story, and something that we should celebrate as that. I think also what has struck me in reading the report is the size and the influence of the field. And I think this is its challenge. I mean, Damon Dowling made exactly the same point a few moments ago. You know, in a way, it's a key enabling technology, which often doesn't get the visibility because it underpins. And why, again, I was really happy to support this report, and I'm really happy to be a champion for what's coming out of this report in some senses, is that, you know, we've got a world-leading science supporting actually a huge UK PLC industry and actually a global industry and global impact. And we've got to recognise that and not let it go back. So I think we have, in this case, and I think the report makes a very strong case for a strategic advantage for the UK in this area, a strong evidence base and a core capability around this. And kind of my statement for Matthew, I was going to use was kind of a Matthew Juniper type statement, is that if you stand still, you go backwards. We know that's true. And I think what this report says, right, actually, we've got a good position, but we don't carry on investing. We don't carry on doing the science, and we stand still and we celebrate that, we go backwards. And I think that's a really, really good thing. So I'm very keen support the recommendations of this, take them into government and be a champion for the science of fluid dynamics and what it can deliver, as well as its industrial impact, which is ideal for somebody who's in the Department of Business, Energy and Industrial Strategy, kind of intersects all those sort of things. So thank you for inviting me to say something about this. It is an amazing report, it's an amazing community. And you know, it's really strong step forward, and I look forward to engaging around making the recommendations that the reports make, making them real, and helping support them land those sort of outcomes. Of course, there can be no promises, but actually I think you've made a really good, strong evidence base, which is going to do no harm at all. So thank you very much for inviting me, and all the best of luck with the launch of this new report. Thank you very much.
Well, thank you very much, Paul. That's great. The other foreword to the report was written by Professor Stephen Belcher, who's Chief Scientist at the Met Office. And unfortunately, Stephen can't be with us today due to a diary clash, but he has recorded his contribution, which we hope to show now.
Well, it's a real pleasure to be able to be present, if only virtually, at the launch of this fluids report. It's a really important moment, I think, for fluid mechanics in the UK, because this report really demonstrates the importance and strength of fluid dynamics in the UK, both from an intellectual standpoint, but also its economic and societal value. Fluid mechanics has been a real area of strength for the UK for really many years now. And as a branch of applied maths, it really gained status probably 30 or 40 years ago, and has given the UK this real leading position. And now you look at fluid mechanics and it just permeates so many aspects of society, health, energy, and of course in my area, weather and climate. I personally was inspired to take up a PhD with Julian Hunt in fluid mechanics in the late 1980s. And what really attracted me was exactly this application of maths and physics to really practical questions, and that led me into weather and climate. Everything that we do at the Met Office is underpinned by fluid mechanics. So the atmosphere is a fluid, air, the ocean is a fluid, water, and the flows of energy and water and matter through the atmosphere and oceans is of course fundamental to climate change as well. So maybe the Met Office provides one example of how fluid mechanics can really be taken from very fundamental research through to computational modelling to something that is very obviously of value to society and helps us all stay safe and thrive. So looking to the future, well, the future looks pretty good for fluid mechanics to me, and again this report I think really lays it out very clearly. With new computers, new types of simulation are going to be possible. No doubt that will open up new theoretical thinking. And when we think about how we can combine that with data-driven methods, there are some really exciting possibilities, and some of which we're looking at in Met Office. The other thing, of course, we need this continued flow of trained fluid dynamicists in the country. It's such a fundamental skill to be able to apply mathematics and physics to these modeling problems, and fluid mechanics really is the prototype modeling problem, but we're seeing that kind of thinking being used in disease dynamics, of course, in COVID, in economics modeling and biological modeling. So fluid mechanics is really a really core skill. So we need those trained people. So to summarize, I really welcome this report. I'm really grateful for the team at Leeds who coordinated it and shone a spotlight onto fluid mechanics in the UK, and really showcase the strength that we've got in this fundamental area, and provide a clarion call for the future for this really important subject.
Oh, well, thank you in your absence, Stephen. I'd now like to hand over to Professor Kath Noakes to present the main findings of the report. Kath is known to many of you. She's Deputy Director of the Leeds Institute for Fluid Dynamics and Professor of Environmental Engineering for Buildings at the University of Leeds. Over the past year and a half, Kath has been serving on the Government Scientific Advisory Group for Emergencies. Over to you, Kath.
Okay, thank you very much, Steve. And yeah, so as one of the authors of this report, I'm really pleased to be able to talk a bit more about it in a bit more detail this afternoon. And as you've already heard, the report determines that fluid dynamics plays a key role for both the industrial health and tackling major societal challenges in the UK. So fluids are all around us. They're the air we breathe, they're the water we drink, the food we eat. They're involved in many of the products and processes that we rely on every day. And I think, as Matthew already stated earlier, fluid dynamics is really the science and engineering of how we understand these liquids and gases. It's how we measure, model, predict and control flows for human benefit. And fluid dynamics has a huge influence on just about every single sector. So liquids, gases, plasmas are integral to a huge number of different products and processes. And this ranges from things which perhaps come to mind very immediately, things like the aerodynamics of flight or the importance for world shipping, through to sectors that are perhaps a little bit less obvious that support our health and well-being. So for some examples, in creating a sustainable environment, fluid dynamics is important for developing batteries, enabling wind power, developing fusion technologies, and designing low energy buildings. In medicine, it's important for things like blood flow in the human body, transmission of disease, but right the way then through into pharmaceutical manufacturing. And if we look at process industries, it's integral to the manufacture of steel, glass, paints, coatings, personal care products, chemicals, you name it, hundreds of different things. But as already been stated, fluid dynamics is a bit of a hidden discipline. There isn't an industry sector on its own that's called fluid dynamics. And I think, except in a small number of cases, such as things like flight, there's really quite a limited awareness of the role that fluid dynamics plays. So this is where the report comes in. So we have taken a much more detailed look at the influence and importance of fluid dynamics across all sorts of different sectors, and to really underpin and identify where fluid dynamics has an impact. And then we've looked at where research underpins this and how we connect between academia and industry. So the key headlines, you've already heard these briefly mentioned already, but the main findings is that in the 2019, we identified that businesses with fluid dynamics activity in industry generated an output worth 13.9 billion. That's over more than 2,200 companies and employs 45,000 people directly to work in fluid dynamics. And these are probably actually quite a conservative estimate, because it's actually very hard to total these things up. Then the gross value added from fluid dynamics is really quite significant. So across the whole of the UK economy, it's around about 3.4 billion, which works out at around £76,000 for each of those 45,000 people employed. But we know that fluid dynamics is actually often embedded in highly diversified businesses. So the total turnover of firms who have fluid dynamics involved in their business exceeds about 200 billion per year. And collectively, these firms employ over 500,000 people. So even though the fluid dynamics proportion of these businesses might be quite small, it's absolutely critical to the success of those organisations. And it enables an economic success and innovation that's far in advance of the direct activity itself. Fluid dynamics is also a global influence, and exports, when we looked at different firms, around 70% of the firms that are involved in fluid dynamics have an export, 3/4 of them export over 20% of their output, and about a third export around 50% of their output. And the primary exports are to Europe and North America, followed by China and other countries in Asia. We also identified that fluid dynamics is a whole nation activity. So the expertise is distributed right from the tip of Cornwall up to the north of Scotland, across Northern Ireland, across Wales. So it's in every part of the UK. There are variations, of course, in output, but output, employment and gross value added are really quite well distributed across the whole of the UK. Where we do see some variations, we tend to see higher activity where we've got large organisations that have big R&D facilities. So, for example, in the southeast, the highest value, and that's because BP have a substantial global R&D facility there. But we also see substantial activity in SMEs, and about 80% of the companies that we identify with fluid dynamics expertise have under 50 employees. And all of this is underpinned by significant and sustained investment in research. So we've looked at the value and distribution of research grants from UK research and innovation. And we can see that, as you might expect, the majority of funding is through engineering and physical sciences, but it's quite well distributed across environmental sciences, astrophysics, and into biological sciences. And we also can see that this is geographically distributed too. Over 75 universities are engaged in fluid dynamics related research. Since 2012, there have been over 3,600 research grants related to fluid dynamics with a total value of about 2.3 billion. And then you can see Innovate UK, the substantial chunk of funding there on the graph, where the research base connects very strongly with industry, and over 300 companies have been supported to develop innovations through this funding. Then when it comes to societal challenges, fluid dynamics plays a really key role in here, both in the research base, through industry, and through a whole raft of other public and private sector organisations. This is much harder to quantify the economic impact, but we know it's absolutely immense. For example, tackling climate change is probably one of the biggest, if not the biggest challenge we face at the moment. And as already highlighted by Stephen Belcher, fluid dynamics plays a really significant role here. So it plays a part in implementing clean energy sources, enabling cleaner transport, enabling better energy efficiency of buildings, and actually understanding the science of how the climate behaves in itself. If we look at productivity and resilience, we can see that advanced fluid dynamics simulation data-driven methods are key to being able to how we advance high-value manufacturing, as well as improving resilience and our resource use. And we've already seen that fluid dynamics is across the whole nation, and actually this offers huge opportunities to the levelling up agenda in employment and in societal contributions to health and well-being through, for example, understanding air pollution or developing new medical treatments. And then we can see it contributes to the capability and global reach of the UK through key strategic areas such as future transport and digital capabilities. And to highlight in a little bit more detail the breadth of capabilities, I would want to share with you 4 case studies. These are really just examples, they're the tip of an iceberg, but to just illustrate both the economic and societal benefits that come from investing in fluid dynamics. So the first case study I want to show focuses on the emissions associated with flight. This is an industry where it is particularly challenging to reach net zero, but by understanding fluid dynamics, we can take some substantial steps in this direction. So we can think about how we can reduce energy and carbon emissions associated with flight. Approaching this means we've got to look at all aspects of flight. So thinking about the aerodynamic efficiencies, the fuels used, the types of propulsion technologies, and evaluating all of the possibilities here is a massive challenge. But this is where a collaboration between Rolls-Royce and Cambridge University comes in. So they've developed new strategies, including things like accelerating their computational fluid dynamics simulations by running their simulations on graphics processing units, using 3D printing to reduce prototype manufacturing times, and using machine learning to reduce design times. And overall, this reduces the design, build and test time by around 15 times, and enables all these new ideas and concepts to be evaluated much more rapidly to identify those with the greatest potential to reduce emissions. The second case study focuses on weather and climate forecasting, and as you've already heard from Stephen Belcher, this is an area where fluid dynamics is absolutely embedded. We use weather forecasts day in, day out to plan our lives. Thousands of businesses rely on both the short and long range predictions to plan on a day-to-day basis and make strategic investments. And really, climate and weather is absolutely derived from complex fluid dynamical simulations of how the atmosphere and the oceans interact together. Over the years, both advances in supercomputing and greater understanding of the underpinning processes and how we model and measure those have enabled more accurate forecasts. And as an example, today's 4-year forecasts are as accurate as the one-day ones from 30 years ago. And these advances happen because of the continued investment in excellent science, both at organisations like the Met Office, but also through a raft of academic partners. And the UK research base in geophysical flows in particular is world leading. And where this is going next, we can see that we've got a new investment in the supercomputing for weather forecasting, which is expected to bring a financial benefit of around £13 billion to the UK economy in the next 10 years. The third case study I'd like to share with you is a real example of what you might call a deep transformative technology. So something that has progressed and matured over many years. So computational fluid dynamics is a methodology. They were first developed over 40 years ago in academic research, and they've transitioned over time from very specialist research tools through to tools that were used first in high value industries and now into tools that are accessible to a whole raft of organisations of all different sizes. Ansys is one of the key players in this sector. They host 2 of the best known computational fluid dynamics tools, Fluent and CFX. And they continue to advance these capabilities through close collaboration and many academic partners. And this support ranges from support to graduate programs all the way through to working in partnership to innovate new methodologies. And if we look at where computational fluid dynamics is applied, the applications are absolutely immense, used from everything from optimizing the aerodynamics of Formula 1 cars that Paul Monks mentioned earlier, designing low energy ventilation systems, through to predicting what happens if we put a stent into a coronary artery. How can we optimize design of domestic appliances? And how can we make sure we've got the best layout for wind farms? So CFD is actually a really good example of a UK fluid dynamics success story, which now has supported research and innovation at a global scale. And actually, I think there's an opportunity now for the UK to lead the way in the next generation here with data-driven fluid dynamics. Final case study that I'd like to share illustrates some of the newer advances that fluid dynamics can bring, perhaps in areas that you wouldn't necessarily immediately think of, but this is thinking about some biological problems. So the focus here is on reproductive health, which, as many of you will know, touches the lives of thousands of people worldwide. And we're looking here at 2 different areas. First of all, pregnancy complications. They actually cost the NHS around £12 million a year, and preterm and stillbirths affect up to 10% of all deliveries. So ongoing research funded through MRC and EPSRC by teams at the Universities of Manchester and Edinburgh are working with NHS colleagues to develop new computational models of blood flow in the placenta, and this will enable new clinical diagnostics and therapies. The second example is around IVF. So there are around 75,000 IVF cycles carried out every year, and there's a really high cost, low success rate, and a physical and emotional burden on patients who are undergoing fertility treatment. And again, through EPSRC and NIHR funding, there's a team at the Centre for Human Reproductive Sciences in Birmingham who've developed a new computer simulation algorithm to understand the behaviour of sperm. That's what you can see on the screen. It's the vortices from a sperm swimming. This will support things like less invasive methods such as intrauterine insemination. And even if only 5% of IVF cycles were transferred onto this approach, that could be an annual saving of around 15 million on top of the reduction in the emotional stress associated with the treatment. So these examples are by no means the only ones. There are thousands more like them, but they illustrate what can be achieved by supporting fluid dynamics. We know fluid dynamics is in a strong position, but as highlighted earlier through the other speakers, we cannot stand still. So we'll only get to the next generation of breakthroughs by effective support. Through our analysis and through a survey of organisations, we see that actually this is an area poised for growth. There are around 4 in 10 companies who use fluid dynamics who expect to grow by over 10% a year, which is really quite substantial. But to enable such growth, we need the right environment. So the examples we've shared illustrate what can be achieved long and short term by enabling these great collaborations. And this needs to be both with the research base and supply chain partners. So we need skills development, support for exports, UK IP, and the right support to leverage investment to enable fluid dynamics to address these really major societal and industry challenges. Our survey also particularly brings out the need to invest in people. We know that fluid dynamics is a really highly skilled profession. It requires graduate and postgraduate level knowledge in many organisations. And when we surveyed organisations, we found that 85% of them indicated a need for research and development staff at postgraduate level, with 35% indicating actually a shortage of supply there. And this becomes even greater when we're looking at experienced technical staff, where 64% are in short supply. So recruitment here is really important, and it highlights the need not just for being able to train at graduate level, but actually being able to train and bring new skills through CPD and the latest technology advances to more senior staff. So to bring this to a conclusion, the analysis within our report highlights 4 key recommendations to take creation of economic growth and societal impacts to the next level. To deliver the sort of transformational change needed, it's essential that we work together and have strong mechanisms to jointly develop and share knowledge and expertise. So our first recommendation is around a national centre in fluid dynamics. This perhaps takes inspiration from ideas like Royce Institute for Materials or Turing for Big Data, and will build on the substantial strengths and existing research and practitioner networks in fluid dynamics that have already been created through the UK Fluids Network. The shape of such a centre is not set in any way yet and would have to be developed by the fluid dynamics academic and industry community. But things that we've envisaged already are shared methods, facilities, training and knowledge exchange, the ability to unify aspects such as exascale computing and data-driven methods, perhaps a focus on a handful of really ambitious research challenges, and then mechanisms to enable the research community to work with industry, with government and local enterprise partnerships to exploit and develop impact from applications of fluid dynamics across every region. Linked to this is the second recommendation. So fluid dynamics training is essential to address gaps in the highly skilled roles that are needed in research and in industry to adopt and effectively utilise new approaches. The centres for doctoral training that have been funded over recent years by UKRI have provided real excellence in postgraduate training, but we now need to continue to support this at graduate and postgraduate level. We need to be able to retain this talent in both academia and in industry to have the next generation of leaders. And then at the same time, be able to support new skills within industry to be able to get these new breakthroughs in modelling and measurement to be realised. Our third recommendation recognises the most recent advances in fluid dynamics. We think we're at a cusp of a new breakthrough where data-driven methods and machine learning type techniques can enable step changes in productivity and efficiency. And we saw that through the Rolls-Royce and Cambridge case study. So this will actually both improve efficiency and productivity in industry, as well as lead to substantial new insights into our fundamental understanding of fluid dynamic processes. And we're seeing examples of where this is leading to new ways of working. There's a real opportunity here to support these approaches and enable, again, new insights into societal and industry challenges. And finally, we're recommending a focus on attracting and anchoring key research and development hubs in the UK. There are already some real examples of high value added research and development hubs such as BP, Dyson and Rolls-Royce, which all are able to attract and develop talented people, support new innovation and ideas through their own activities and through partnerships with academia and through their supply chains. So enabling generation and retention of IP is critical to the UK's ambition to be a global leader in science and technology. So to close, I think this report is the first time that fluid dynamics in the UK has been analysed to this depth. And we can see that the impact on both the economy and society is really substantial. There are some huge opportunities ahead for fluid dynamics, and I think by working together, we can realise these to deliver economic value and play a leading role in new solutions to some of the really big global challenges in the world. And I'd finally just like to say a few thank yous to all those who've made the report possible. So it's been a pleasure to write this report together with Steve and Matthew and Claire. I particularly want to acknowledge Dr. John Lincoln from Harlan Limited. He put all the hard work into the really detailed analysis of understanding the role of fluid dynamics in industry. And then I'd like to say a thank you to all of the people who have spoken today at this event and will speak on the panel later, and the whole raft of people in the UK Fluids Network, Leeds University who supported this report, many experts in industry who supported the apportionment process as to how we worked out all the different industries involved in fluid dynamics, and then a raft of colleagues across academia, industry, UKRI and EPSRC who've supported data, case studies, quotes, images, etc. to make the report possible. And thank you very much. I'm going to hand back to Steve now.
Thank you, Kath. Thanks. So our final speaker before the break is Dr. Andrew Lawrence. Andrew is the Head of Engineering Capability Delivery at EPSRC. So over to you, Andy.
Okay, so welcome everyone. I think we very much, on behalf of UKRI, welcome this report. We'd like to thank the UK Fluids Network and the Leeds Institute for Fluid Dynamics for hosting this event as well. I think it's a really interesting and insightful report with some really useful recommendations going forwards. So as indicated in the report, there are many funders that contribute to our world-leading status in the area. And UKRI's investment over the last 10 years has been significant, to the figure of 2.3 billion. And if you compare that to the headline figure that was mentioned in Kath's talk of directly generating 13.9 billion in 2019 of fluid dynamics industries output, then potentially there's a really high return on investment there. And I think that's something that really can't be ignored. UKRI, as many of you will know, consists of all the research councils and Innovate UK, and is, amongst other things, a vehicle to enable greater interdisciplinary working. And fluid dynamics is one of those areas that cuts across the many interests of UKRI, and therefore there's substantial potential for greater interdisciplinary working going forwards to progress these new innovations in fluid dynamics and to tackle these multiple major societal challenges across industrial, biomedical, astrophysical, and environmental sectors, amongst others. And of course, UKRI's interest and encouragement for fluid dynamics is also fueled by its role in making the difference across a wide variety of important problems, and where fluid dynamics can play a crucial role in clean growth for a post-COVID economic recovery. And whilst we're not there yet, we can see a clear alignment to enable clean and efficient energy solutions, monitoring and modelling virus transmissions, understanding the impacts of space weather, and mitigating the effects of river and coastal flooding. All of these align to UKRI's goals going forwards, and of course the UK's goals as well. So in terms of EPSRC, over the last few decades, we've had a history of supporting fundamental and applied fluid dynamics research. And we've been building and strengthening those foundations across multiple institutions over the last decade. And again, a figure from the report that Kath showed on her slide was £1.2 billion investment over the past decade from EPSRC. And fluid dynamics and aerodynamics continues to be one of EPSRC's largest research areas. with a current portfolio of £85 million, which is around 154 grants. And I would say most of them are competitively won investigator-led projects and programs, which highlight the prominence and excellence of our research base and the world leaders that we have in advancing this field. But in addition to the transformative research projects, EPSRC have also invested in some real key initiatives, particularly over recent years, such as the UK Fluids Network, the National Wind Tunnel Facility, alongside the Aerospace Technology Institute, and a number of centres for doctoral training, including the current one at Leeds, all of which have played a part in progressing innovative developments and applications and contributed to a vibrant and world-class research community that we see today. So inevitably, because it's such a broad strength and vital to the UK future, we will continue to support fundamental and applied research challenges in fluid dynamics, but also seek to define and catalyse new collaborative and coordinated opportunities in the area. And it is, as Kath said, working together across the whole research community to enable this to happen is really important. From EPSRC's perspective, of course, there's all the usual standard competition mechanisms, standard mode, new investigator awards and programme grants represent open opportunities to support investigator-led research in this area going forwards. And many of my other colleagues across UKRI will speak on behalf of their councils in the open opportunities they can also present to support this area. But of course, let's not forget about the people. So without skilled people and the ability to retain the next generation of world leaders in the UK, our position to have fluid dynamics as an academic and industrial strength is simply not sustainable. And as Kath already highlighted, the report highlights there's an important need to advance graduate skills to harness the opportunities for fluid dynamics, which is critical for UK's future economic success. So it's at this point I'd like to pre-announce one of these collaborative opportunities focused around skills, and that's a new fellowship call that EPSRC will run in the near future. And these are the National Fellowships in Fluid Dynamics, or NIFTY. So we have been working with the UK Fluids Network for quite a while, over the last year or so, to develop an opportunity with the intention to support a UK-wide cohort of postdoctoral fellows in 2022. This is essentially a pilot fellowship opportunity. It's a new one that will enable the most talented PhD graduates from a wide variety of disciplines to progress research in computational and data-driven fluid dynamics and empower them to become agile, multidisciplinary, independent research leaders that contribute to the advancement of the field in the UK. So this is one of those opportunities which is still in development. So we are expecting to launch the course at some point in the autumn and winter 2021. That is a rather vague timeline, but there is some work to do with the UK Fluids Network and the community to make sure that the scope of it is actually suitably ambitious and really takes advantage of our world-leading research base. But of course, we will be publishing further details on this in due course, and we'll be publishing through all the usual channels, including the Fluids Network, and trying to cast the net as wide as possible. So this opportunity really represents one intervention by which we want to secure and retain the best talent to be able to capitalise on our strength in this area, but also make the most of future opportunities of fluid dynamics. So watch this space. So just as a final comment, on behalf of UKRI, we really welcome this Our Fluid Nation report and its intentions to demonstrate the value of fluid dynamics to the UK, and particularly to give foresight to what opportunities might arise for further productivity, new innovations, and positive societal impact. Thank you.
Well, thank you very much, Andy, and for announcing a very exciting opportunity there. So that's the final talk before the break. We're now going to schedule a brief 5-10 minute break, probably closer to a 5-minute break, and then we're going to have a panel discussion. So I'm sure there are many questions that you would like to ask for the panel. So please put any questions that you have in the Q&A window, and we'll endeavour to answer as many as possible after the break. So thank you all. Welcome back, everybody. We're about to start the panel section of our launch. You've already met most of the people on the panel. But there's one panel member who I'd like to introduce. I'd like to welcome Dr. R.V. Ahilan to the panel. Ahilan is Chief Energy Transition Officer for Aqualis Bremer LOC. And this is a leading independent global energy and marine consultancy working in energy and oceans to de-risk and drive energy transition. So I'm going to chair the session, and I'm going to use a mixture of the questions in the chat and questions that had been sent in earlier for those people who couldn't make the actual launch. So I'd like to ask the first question from the Q&A, and it's from Omar Mata from Imperial, who says, do we not have a strong case for the establishment of a National Institute of Fluid Dynamics, e.g. Royce, Turing, etc., where we can connect academia, industry, government, etc. in addressing global grand challenges? This institute would have a truly international dimension. We can exploit our very strong international network and collaborations, something to consider seriously. So Omar is stressing the international dimension. Maybe I'll open that up to Matthew to start off with, and then other people can jump in.
Thank you, Steve. I mean, clearly, Omar, yes, we want to make the best possible case for it. Ultimately, that's a political decision, but I think what we want to show is this is a subject that impacts people across the UK. I mean, the gross value add in the Northwest, I'm looking at it now with 3,000 people, is £81,000 per person. You know, that's well in excess of what you get for gross value add per person in London. You know, this is a big thing at the moment is levelling up. This is really levelling across, that everyone has something to benefit, everyone has something to give. It's a really great subject for that. It's, you know, everyone can be included. I think there's a big question about what one would do with a national centre that would have to be developed from the bottom up. I think we have lots of ideas. There's no shortage of ideas there, but there'd have to be some sort of collaborative process to work out exactly what it would look like. But certainly, I think it would involve some sharing of experimental equipment, data acquisition kit. One big change in the last few years, as we know in computing, is that researchers would much rather rent than buy. So you'd much rather rent time on an HPC than buy the HPC itself. And increasingly, we're going to see that for large items of experimental kit. And the National Wind Tunnel Facility is a good example of that, where you can upgrade and share facilities for everyone. And I think in terms of, as you said, Omar, the sort of ambitious challenges, you know, there may be 9, that sort of number, a handful that we'd really focus on. Clearly, there's data in fluids, but then there are things like fluids in healthcare, fluids in cities, smart CFD, and so on. And I think if you had a big centre, I mean, one of the big gateways for a lot of what we do is the CFD companies, like Comsol, like Fluent, because most users of CFD are using Comsol or Fluent. And one way to, well, really the way to get stuff from academia to everybody is through these gateways, and having a larger group of people able to talk to Comsol and Fluent together, you end up with well, everyone's a winner. For the application, people who make Comsol and Fluent, they have access to lots of expertise across the UK. For the users, they've got access to better CFD. And for us in academia, we get a route to market for what we do. So I think there's a great case for it, and we want to make that case as well as we possibly can. Steve, I'll stop there.
Thanks, Matthew. I think Kath has a point.
Yeah, I think collaboration is a really key part of this, and a centre would, I think, has a really big role to play in how it enables people to connect together, and I think can also enable not just connections within the UK but internationally as well. So provides a hub for people to visit, provides a hub to leverage other funding from, and provides a place for people to come and share ideas and share knowledge. I think the other thing that a centre can do is to really raise the public profile of fluid dynamics. I think it is a lot more hidden than for something like materials, where, you know, you can do, if you're a kid in school, you can do design technology and resistant materials, whereas you can't study fluid dynamics at school. It's a bit hidden. And I think a national centre really can raise a profile there and highlight some of the real advances and real impacts that we do. And I think fluid dynamics, you know, it's a very visual discipline as well. I think there's some real beauty in it, that, you know, some stunning pictures that can really inspire people.
But I also, after you, Anne.
I think collaboration with business could really be enabled through having a focus of a centre. Some of the the big corporates, whether they're in energy or aerospace, have got well-established ways and they know their way around academia. But because your study has shown such a high amount of work going on in SMEs, and that's probably going to increase, you know, as we see some of the new technologies being developed within SMEs, they find it much harder. They haven't got much time, the time poor, don't have those contacts necessarily, and actually having a hub to go and get quick advice and routing to people who would be the right experts. So almost a kind of nearly informal drop in, get some quick advice fairly easily, and then maybe help to find you know, the real experts in what they're interested in. I think could be a real focus for enhancing collaboration.
Yeah.
Thank you,
Actually, that reminded me, Anne, that this is a very important point, because now we are starting quite a big transition in energy, which is going to bring about new companies as well, who will not know how to go navigate this, the requirements, and therefore, and I think Kath made the point in her talk earlier that climate change for me is the defining problem of this century, and that's actually in a scale that actually requires some concentrated power. And I don't mean by that one particular location, but actually concentration of networks that are that you can come together and say, we are going to attack this big problem. So I think those are some of the reasons why I feel it should be raised. And of course, fluid dynamics is underpins everything, as I've just heard. I think practically every physical sector is influenced by fluid mechanics in one way or the other, fluid dynamics.
Thank you, Ahilan. I think I'll move on to the next question, and this one's probably for Andy, and I think possibly Andy's typing an answer, but I'll ask it anyway. Maybe he's answered it. So I'll ask it. Will these fellowships be limited to experts in computational fluids?
I think we're obviously still developing the scope of the opportunity, but I think we expect it to be open to a wide pool of applicants from across many different disciplines. We really want to try and capture expertise from outside the traditional areas and bring them into the area of fluid dynamics to really look at these data-driven fluid dynamics challenges. And so I think anyone who's able to apply their skills towards those sort of challenges, we would encourage to apply for this opportunity. I think on the other part of that question about numbers, I think we're anticipating adopting a cohort approach, so we can add a lot of value onto their own learning by involving them in a number of different cohort type training activities. And I think we're looking at sort of 10 to 12 fellows in the first instance, recognizing this is a pilot opportunity. But like I say, the details we still need to work on, but I think that's the gist of it.
Thank you, Andy. Is that hand raising, Matthew, or are you just looking pensive?
It was a slight hand raise. I think that the question is, you know, where does the data come from, really? And can the data come from experiments? Absolutely, yeah. So I think this is this is not saying data comes from CFD. This is saying that if you have an experiment with lots of data, that would, I'd have thought, be a really good thing to look at with this sort of fellowship.
Thank you, Matthew. Okay, if there's no further comments, I'll move on to the next questions, because we're getting questions left, right and centre here, which is good. So there's a question from Prashant, who says, it's paramount that as a world leader and a pivotal player in fluid dynamics, we must strengthen our collaborations with the rest of the world. This will be key for ensuring intellectual and economic export and our pivotal position. I would really appreciate your thoughts on this and how we can enable and strengthen global interaction. So I don't know, would anybody like to take that one first?
So I think I absolutely agree, and I think a centre can provide the mechanisms for how we can do that to some extent. So I mean, I think we need a whole raft of different mechanisms, right from, you know, undergraduate exchanges, PhD student exchanges, through up to, you know, collaborative research grants, and through recognising where there's opportunities with industry to connect together worldwide. And so some of this will come from quite low cost things of simply sharing information together, enabling people to connect up. And I think the one thing the pandemic has shown us is that we can connect digitally so much more easily now than we ever could before. But that face-to-face stuff is really important as well. So I think having mechanisms by which we can develop sustained relationships, and some of that will then require funding. But I think, again, that's where having a really strong relationship with UKRI, and I know UKRI are busy developing relationships internationally, I'm sure Andy can comment a bit more about that, really will allow those things to be driven effectively.
Okay, thank you, Kath. Maybe I'll move on to the next question, if I can. So there's a question from Doug Greenwell, which says, would the National Centre be virtual or physical organisation? In aerodynamics, for example, experimental capabilities in UK universities are rather fragmented, lots of small facilities and labs, but perhaps insufficient critical mass to support the larger facilities seen in universities in other countries. So maybe I'll pass that first to Matthew, I think. And
thank you, Stephen. I think that's a very good question, a very difficult one to answer. Maybe if one considers perhaps merging in with the previous question, what do other countries have that we don't have? And the things I can think of most are HONORA in France, DLR in Germany, long-term infrastructure investments that are over decades. And that enables research in a way that we don't do in the same way in the UK, because we tend to fund over shorter periods. So when it comes to collaborations, I think a key thing is to look at what other countries do really well that we don't do, and equally from the other person's perspective, what do we do really well that they're not doing? So how can you complement each other? And then you have to find mechanisms for joint funding. So in a way, yes, I think we should look at this. Any national centre should be looked at within the context of the globe, not just within the context of the UK, to say, what can we do that others aren't doing? What can we really excel at? And frankly, reacting quickly is something we do very well. And perhaps that's because we haven't invested in really, really long term. But on the other hand, it's what are other people doing where we can use what they've done. Now, mechanisms for that, I've always found summer programs to be very good. So where people geographically come together for 6 weeks and work together on a common problem, where they're slightly scared of being shown to get it wrong or to not work hard enough, so tend to do lots of the work before they arrive. So there are things like that that are ways to work together. As to sort of what a national centre would look like, I think this would have to really sort of go out to the community for discussion. I can only guess. I mean, if we look at Royce, for example, Royce, which is probably the closest thing to what one might propose because it's a discipline focused. It's obviously sort of based in Manchester, but with many very significant hubs around the UK, specialising in certain areas with particular challenges. And that may well be a good model, but I don't think that there's certainly been there's been a bit of discussion about what it might look like, but nothing more than discussion about what it might look like. So the answer is I don't know, Steve, but I think it's something that we're very conscious that we need to think about and have thought about in some respect, but also very conscious that we have to think about it with everybody.
Thank you, Matthew. I think I'll move on to the next question. There's a question from Anne about the fellowships and Jewel, but I think that's been answered by Matthew. So it's really open to all areas of fluid dynamics, be it experimental or computational. So yeah, absolutely. Okay, I'll move on. So I'll paraphrase this question. And some benefit should be given to undergraduate students to drive them into this sector, which I think is a very good point. How are we going to attract people into doing PhDs in fluid dynamics? Maybe this is something that a national centre could help with, and it also comes into various considerations that I guess the CDTs have been struggling with as well. How do you attract to a wide pool from a wide pool of applicants? So I think maybe I'll ask Kath if she can comment on that.
Yeah, I agree. I think we should look at highlighting benefits for undergraduate students. An awful lot of undergraduate students have the opportunity to do work, particularly project work around fluid dynamics, and ways in which that can connect up can enable them to gain a much richer experience. I think also there's a real opportunity there for industry collaboration and how we can use the mechanisms to enable the right, really strong graduates to go into fantastic graduate jobs and build their skills through what they've learned in their undergraduate degrees. So I think there's definitely some real opportunities there, and we shouldn't just sort of badge this around, PhD and above.
Anna, I believe you probably have some experience in this field. Would you like to comment?
Well, I'm not sure if I've got much experience, but I mean, as an undergraduate, I did two vacation placements that really attracted me to what became my research area. So I really think if we could get the industry network working on this problem and really flagging that this was fluid mechanics opportunities to students. So often students just go for an employer and don't really get a say, in what they do over a summer placement, but sort of treating it perhaps as a lead into a specialization could be very attractive. And I've seen that myself with students who've done a precursor to their final year project in the summer with a company. It gets them off to a great start in their final year project. And the company was recruited some stars, absolute stars through that route. So it can be win-win to get companies involved in, selling the story of fluids.
Thank you, Anne. That's great. Okay, let me move on to another question. This is from Yongyung Wang. And Yongyung asks, the report points out the needs of training more postgraduate students. However, the standard response mode EPSRC grant does not allow for PhD studentships, and the number of CDTs was reduced from 2 to 1. I personally found it very difficult to find funding for PhD students. I understand there's a problem shared with many colleagues. So Yongyung was wondering whether EPSRC have any plans to address this.
So we've just gone through a doctoral review of our doctoral training programs. I think that's going through our council at the moment. So I think there will be some views taken on how we should best support doctoral training in the future. So I wouldn't like to sort of pre-announce any of those recommendations yet, but I think it's obviously something which is an issue across the community, not just within fluid dynamics, but also across the entire sort of engineering and physical sciences landscape. So I think, I think that's the situation, but I think we're fully aware that there is more need to support doctoral students across the UK, but I think it comes down to the limits of the funding as well, and being able to influence that sort of position to the budget holders.
Okay, thank you, Andy.
Can I just make a comment?
Oh, yes.
Sorry.
Yes.
Go for it. So, okay, I'll shoot very quickly that in my experience, a lot of the contacts between industry and academia for postdoctoral PhD research is actually very ad hoc to me. Even when my company has supported them, it has happened because of almost personal connections. And I don't know whether we can make some improvement to that through concentrated effort to identify where the additional funding may happen. And I think this is true of many universities, and a lot of the support I have provided have come about through very random means. So maybe that's something that we should pick up and make sure, and who knows, I think if one was more systematic, perhaps there is more money available in the industry to support PhD research.
Thank you, Ahilan. Anne, did you have a?
Well, yes, I know from time that I've spent on EPSRC Council that there was a concern of overproduction of PhDs. Academics like to have them, they're sort of cheap pairs of hands that you can get to do just what you want. And so there was a concern that these PhDs were being turned out and not going into PhD level jobs. So, but the CDTs give a way of focusing the effort. And I think since this report has so clearly identified a need for PhD level employees in industry, then there ought to be a real way of scaling that up rather than scaling up across the board in just PhDs. That could well lead to problems that were there in the past. So I would suggest that studies like this ought to be done to identify exactly where an expansion in PhD numbers should be, and not just make it carte blanche for any subject. Because you've got to think of the future of the young people that go into, you know, devoting 3 or 4 years of their lives to that training. But I really believe here that work has already been done to show the need in high value added businesses.
Thank you, Anne. Thanks. Okay, I'm going to move on to the next question. Gosh, we're rapidly running out of time. So this question is from Tim Kruger, who asks, Germany has a series of research societies and organisations that sit between universities, fundamental research, and industry application, such as the Max Planck, Helmholtz, etc., etc. This is a very useful and successful format, and the UK could learn from it. How could we take advantage of this? Is there somebody who might want to answer that question? Or how might a national initiative or centre help with this? I guess I'll rephrase the question slightly. I'm going to pick on somebody. Go on, Matthew. Oh,
I was busy staring at my shoes just then, Steve. I'm not so familiar with Germany. As it happens, I live next to one of the directors of the Max Planck, who's British, but who goes there every year. I would certainly ask him. Were we to have the opportunity as a community to do something big with a lot of money to make a centre, we would definitely have to first of all look at other examples across the world, and I think the Max Planck would be a really good example of that. I think maybe I'll just leave it there.
Okay, thank you.
Just again, from my experience, maybe the question may correct me, is that Fraunhofer Institute, again, in Germany, has been really influential in some of the renewables developments that have gone on. And I don't see a parallel effort in the UK. Maybe that should be part of it.
Thank you,
I hope I'm not doing a disservice to anybody.
Okay, I think I'll move on to the next question, which is from Jason Boateng, and I'm going to paraphrase it. So does the panel think more can be done in terms of outreach, specifically in the undergraduate sector, but I think we could interpret it more widely in order to meet the needs of trained fluid dynamicists? So I think I'll ask Kath.
I agree. I think they should, and I think one of the challenges with outreach is that fluid dynamics often features in outreach, but it's never called fluid dynamics. So you do the outreach around climate science, or you do the outreach around net zero, or the outreach around a medical technology. And I think what we need to do is make sure that, you know, we don't rebadge it fluid dynamics, but we make sure we mention fluid dynamics is the important underpinning technology that enables that thing to happen. And I think that's where raising awareness. I remember doing a talk at my son's school 2 or 3 years ago. Strange now, because I did it on airborne infection in buildings, and it's amazing what you can preempt, isn't it? But I had one of the kids came up to me at the end of that full of enthusiasm, and he went, I never knew there was something called fluid dynamics. Where can I learn fluid dynamics? Can I go to university to study it? And I explained to him then that, well, yes, you go and study mechanical engineering, or you go and study mathematics, and those are the places where you find your fluid dynamics. But you suddenly realize that there's a whole group of people who are completely unaware of this and suddenly realize it matters. So I think we need to be able to, we want people to talk about it in the same way that perhaps people talk about materials.
Okay, that's a good answer. So I'm going to go on to the next question, which I'd like the panel to kind of interpret it in a kind of broader way. So then it's from Andrew Ross. The Newton Fund has been a very successful mechanism for fostering research collaborations with developing countries. How can we harness this to help cement our position as a global leader in fluid dynamics, as well as generate real global societal impact? So I think that's a question which could certainly be interpreted more widely. Kath.
So I think, I mean, obviously the Newton Fund is in part successful because it is a fund and people like to apply for funds. But I think there's also a success there in that it asked people to focus on particular challenging questions. And it enabled, because you put those questions to people, it allowed people to come together who perhaps would not necessarily have worked on a particular problem together before. And I think that's again where there could be some opportunities here. So could be funding or could not be, or could be through other mechanisms, which is about how you enable those challenges. And that's where actually, as well as working within and across the discipline of fluid dynamics and bringing together people with different skill sets from different areas of fluid dynamics, we can't do this alone. So we will have to then collaborate with materials, we'll have to go and collaborate with architects, we'll have to go and collaborate with clinicians, we'll have to find all those other people. So I think posing challenge-led initiatives are ways in which you can leverage something in here. And I think the Newton Fund actually really did focus on challenges that were particular to those countries. You'd obviously have to think about that in other ways, but I think that is one way in which you can do it. And I know there are already some really nice examples, for example, of real-time weather forecasting in Africa through the Africa project, which actually really highlights how you can use the fluid dynamics to provide real-world benefit to farmers in Africa to use the weather forecasting.
Yeah, thank you, Kath. I'm going to move on to the next question. So it's from Kieran Looney, who asks, moving forward, how important do you believe integrating fluids analysis with their influence on the boundaries? These may be material morphologies influenced by heat delivered by the fluid, or solid structures impacted by fluid pressures, etc. If important, we need to integrate CFD with FEA models of structures, etc. So do we need to look to other disciplines and collaborate with those, like fluid structure interactions? Anybody who would?
I agree. I think we do. I mean, I think it's there's no way we can do this on its own, and the advances that are going to be needed in fluid dynamics don't just come from understanding a fluid. They come from understanding how the fluids interact with surfaces, how they interact with chemicals, how they interact with biological matter, and that's where some of the real advances will be. So yeah, I think absolutely it needs to connect across.
Thank you. Anybody else? Okay, we're rapidly running out of time, so I think we'll go on to the final question. So the final question is from Zahir Hussain, who says, thanks for pushing this with the report and the findings. If we exploit our collective expertise through a National Institute for Fluid Dynamics, both at UG, PhD and postdoc level, could we pursue something like professional accreditation via the Institute? For example, undergraduate degrees, PhDs and PDRAs could be affiliated with and accredited by this National Institute. Okay, it's an interesting question. Would anybody like to say anything on that?
I think one thing we have spoken about a lot is CPD, so continuous professional development, in the knowledge that there are many people in industry who maybe did a PhD 30 years ago and would like to come back and refresh on what the big updates are. We certainly thought about that, and of course, and that's a sort of one level, which is a rather informal. Obviously, there's the working with, hopefully, if there were an institute, it would be embedded within universities in some form. So there'd be already the undergraduate degree awarding power through there. I think these are questions we would just have to sit down and work out if we have the opportunity to do it with the community. I don't think we've really thought through anything more concrete than just thinking this is something we need to think about. So I don't know the answer, but it's definitely a good question.
Okay, well, thanks to the panel. Thank you all for joining us today. I'd like to thank all the speakers who's taken the time to come and present the findings of the report. And I'd like to thank you all for attending. And we hope to run some follow-ups to this. So if you have any questions, there's been some talk in the chat about how you can follow up. So please have a look at the chat, and we hope to engage with you in the near future. So thank you all very much.